and it means it's approaching from the right with numbers larger than -3. So I see that the y values go to infinity. So I will say f of x gets it or approaches positive infinity. Very good question. I did not mention this notation because I put everything in a chart and I studied the signs left and right. So I thought that at this point in time, this notation is not, we're not going to use this notation in calculus. We have a different operator that we use. Very good. Anything else? Would you like to work on any of the rational functions, or I move on to inequalities? Yes, please.
51 on page 407.
51 on 407, and Charles?
Quick question. For the homework, I kind of got thrown off when it comes to finding the x and y stuff. I know when you find the x, you plug in 0 for y and vice versa. But is there a certain time when you would do the different quotient or complete the square formula?
I will never complete the square unless you force me to.
Okay.
On a quadratic function, on a quadratic equation, I will never complete the square. Because I have the quadratic formula. If it's not factorable and if it's not already set up to take the square root, I will never complete the square.
So if it's not factorable, then the quadratic formula is not accepted. Okay. Great. Thank you.
Sure. Anything else before we look at 51 on page 407? Okay, 51, 407. 51. Very good. So this is g of x, which is 1 over x plus 2, everything squared. Perfect example. I summarize all my information in the chart. Why? It's easier for me to see. But you're not required to use the chart. If you would like to use a different method, I'm fine. I have to find the domain of this function. Can anyone give us the domain? Very good. Obviously, this function is undefined at -2. That factor doesn't go away. I know exactly that x equals -2 must be, say it again, must be, x equals -2 is vertical asymptote. Perfect. Once I say that it's a vertical asymptote, I know left and right I have to have infinities. So let's plug in -2.1 and -1.9. Notice that I do not put these numbers in the chart. I'm never going to plot something like that, but I need to find the sign, just the sign of the infinity. So when I plug in here -2.1 plus 2, what sign do I get? -2.1 plus 2. But I have to square it. So what will be the sign of this infinity? You agree? Yes? Good. Now plug in -1.9 and then plus 2, and you get, and you square that. So the sign of this infinity is positive. Do we all agree with this? Don't be shy. Is this okay? Okay. Now let's plug in 0. 0 plus 2? 2. 2 squared? 1/4. Can this function be 0 so I can find the x-intercept? Can this function be 0? When is a fraction 0? No, no, no. I'm not asking when it's undefined. I'm asking when is a fraction 0?
Oh,
right. Can the numerator be 0? No. So does this function cross the x-axis? Are there any x-intercepts? Are there?
why you said that you
So I asked, when is this fraction 0? So I can find the x-intercepts. So I'm trying to solve the equation g of x equals 0. And then I write 1 over x plus 2 everything squared equals 0. When is a fraction 0? Can this numerator be 0? No. Are there any x-intercepts? No, because the numerator is 1. It doesn't have x in it. It will never be 0, right? It's 1. Cannot be 0, right? Good. So there are no x-intercepts. Now I need the end behavior and the horizontal asymptote. What do we know about the case in which the degree of the top, what is the degree of the top of this? Degree. I'm not asking about the power of 1. I'm asking about the degree of the polynomial at the top. 0, of course, there is no x, right? There is no x. So the degree at the top is 0. What is the degree in the denominator? 2. So every time the degree at the top is smaller than the degree of the bottom, at the bottom, what is the horizontal asymptote always? Zero. Absolutely. So the horizontal asymptote is always 0. Please look back at your notes. When the denominator has a higher degree than the numerator, at infinity, it approaches 0. Good. That's all I need. And the function is not symmetric. You can write that f of negative x does not equal f of x, and it does not equal negative f of x. Not symmetric. Okay, so let's graph it. When I graph a function with asymptotes, what do I have to graph first? Absolutely. And it has 2 asymptotes, one at negative 2 and one at 0. Of course, I should not, this is an overkill, or because the x-axis is still there. It's always there. So, but anyway, good. So now let's read my chart, or the chart, please. Here's how we do it. From approaching 0, it will go to infinity on the left-hand side of the vertical asymptote. From approaching 0, it will approach infinity on the left-hand side of the vertical asymptote. From approaching 0 up to infinity. 0 for x, 1/4 for y. Oh, yeah. I'm sorry. It's right here. I have to plot 0, 1/4. On the other side, from positive infinity, it will come down to 1/4 when x is 0, and it will get closer and closer to 0. From positive infinity, it will cross the y-axis at 0, 1/4, and it will get closer and closer to 0 as x increases, without bound, we say. So this is the function f of x, which is 1 over x plus 2 everything squared. Very good question. Anything else? Is there anything else you would like to go back to? Any questions? Okay, I would like to look at one word problem on page 408. 101. So we're given a function f of x equals 6.5 x squared minus 20.4x plus 234 divided by x squared plus 36. And we have a bunch of questions to answer here. So this is the pH level, which is f of x, of the human mouth, x minutes, so x is in minutes. After a person eats food containing sugar, the graph of its function, of this function, is shown in the figure. I'm going to copy the graph for everyone to see. So it's something like this. Question number 1, or part A. Use the graph to obtain a reasonable estimate to the nearest tenth of the pH level of the human mouth 42 minutes after a person eats food containing sugar. What will you say approximately from the graph? I would say 6. At 42, I would say 6. Would you agree? So I will say from the graph I read 42, 6. This is in minutes, and this is the pH level. By the way, is this a rational function?
Yeah.
What is its horizontal asymptote? Okay, what is the degree of the top? What is the degree of the bottom? So it's not the case of something small over something big. So how do I determine the horizontal asymptote in this case when I have same degree over same degree? It's not 0. It's not 1. We cannot pick and choose. You have to look at the function. Say it louder. The leading coefficient of the top of the leading coefficient of the bottom. So what is it? What is the leading coefficient of the top? Correct. What is the leading coefficient of the bottom? So what is the horizontal asymptote? Thank you. Okay, part B. After eating sugar, when is the pH level the lowest? After how many minutes? I put sugar in my mouth. After how many minutes will the pH level be the lowest? It will be when time is 6. It's when, right? So in part B, I'll say when time is 6 minutes, pH level is the lowest, and I will read it, as you said, roughly 4.75. Okay, part C. According to the graph, what is the normal pH level of the human mouth? So I put sugar in my mouth. 6 minutes later, my pH level dropped to 4.75 from 6.5. And then, assuming I'm not continuing eating sugar, I leave it alone, and then the pH level continues to come back to normal. What is the normal? 6.5. The horizontal asymptote, the tendency, the pattern, right? It goes back to normal. So C, normal, appears to be the pH level of 6.5. Okay. Part D. What is the equation of the horizontal asymptote associated with this function? How much? Y equals, it has to be an equation. I cannot say the horizontal asymptote is 6.5. I have to say the horizontal asymptote is
6.5.
Y. It's an equation. Y equals 6.5, correct. Use the graph to describe what happens to the pH level during the first hour. Can anyone just tell us what happens in the first hour? And then we move on to 3-6. What happens in the first hour? So at time t equals 0, the pH level is 6.5. I swallow something having sugar in it. 6 minutes later, it drops dramatically. In 6 minutes, it drops dramatically to 4.75. And then it continues to increase till eventually levels off after a while, let's say an hour, to or closer and closer to 6.5. A lot of effort was put in this. A lot of study was put in determining this function. It wasn't easy. Okay, very good. I would like to look at inequalities now, which is 3.6. Polynomial and rational inequalities. Okay, I'm going to choose a couple. Let's say problem 7 on page 420. X squared plus 5x plus 4 greater than 0. So what type of inequality is this? And we know several. We know how to solve linear inequalities. We know how to solve compound inequalities. We know how to solve absolute value inequalities. What type of inequality is this? Yes, it is quadratic. Obviously, I have to determine the zeros. And I see that this is not difficult to factor. So how do I factor this? Very good. X plus 1 and x plus 4, correct? Good. Note, if you want to choose, or I'm sorry, if you want to use the method I like to present or use when I solve polynomial or rational inequalities, then you have to make sure that one side of the inequality is a ratio or product, and the other is 0. So if you want to use my method, you have to make sure that one side of the inequality is a ratio or a product, and the other side has to be 0. I already have that situation here. One side is 0, and the other side is a product. Therefore, I can use the following chart. X is the variable in the problem. The next row consists of the first factor, the following in the next factor. And in this case, I have only 2 factors, and the last row is x plus 1 times x plus 4, exactly what I'm interested in. So, one more time, the chart requires a product or ratio and 0. In the first row, I put the variable in the problem. This problem has x, and x can go from negative infinity to positive infinity. Now I have to determine the value that makes this 0. Can anyone tell us what is the value of x that will make this 0? Negative 1. What is the value of x that will make this 0? Therefore, I have to put them in correct order. Negative 4 is first, negative 1 is second. In the row of x plus 1, I have to write 0 under negative 1, because that's where x plus 1 is 0. In the row of x plus 4, obviously, I have to write 0 under negative 4. Now, let's analyze this. What type of function is this? Just this, x plus 1, linear. How does it look? 1 or 2?
1.
1. So what is coming from? For which type? From which type of values of numbers? From negative to, okay, negative to positive. What about the second one? Is it the same? So negative to positive. Now, this product, when x is negative 4, what is it? You don't have to plug it in. One of them is 0. You don't even have to think. At negative 4, one of the 2 factors is 0. You don't have to think. What is the answer?
X plus 4.
0. At negative 1, the other factor is 0. You don't have to think. What is it? Perfect. So now I see that I have 3 subintervals. 1, 2, 3. When I multiply a negative by a negative, what will be the sign of the outcome? When I multiply a negative by a positive, what is the sign of the outcome? And when I multiply two positives, now, only now I look here. And I ask myself, what do I choose? What sign will that be? Would you agree? So I'm asked to find x such that this product is greater than 0, which means wherever this is positive. Is this positive anywhere? It's positive here and it's positive here. And for what x values is that positive? So x in the interval negative infinity, negative 4, union negative 1 to infinity. If you consider this too much writing, I would understand. You can use the method in the book if that's what you want. I'm fine. Now, this was a quadratic situation. I'm going to move on to 31, and then I'll ask you if you have any questions. 3 minus x minus 5, less than or equal to 0. Obviously, this is already set up for my chart. Why? I have 0 on one side, it has 0 on one side, and it has a product on the other. So it's chart ready. But now when I write it, when I create the chart, so this is the variable in the problem. The first factor is x. The next factor is, instead of writing it at 3 minus x, I'm going to write it as negative x plus 3 in descending order. Then the next one is x minus 5. And what will I have in the last row? What do you think I will have in the last row? The whole thing, of course. That's the target. Very good. Perfect. Now, which numbers go in the chart? I know x can be any real number. But there must be one number for each linear factor that I have here. And what are they? 5 is 1 from here, yes. 3 from here, and 0. I need them in ascending order, from left to right. Very good. X has a 0 under which number? This row has a 0 under 0, correct, of course. This row has a 0 under, and this row has a 0 under 5. Good. What will you say about the product under 0? What will you say about the product under 3? And the product under 5. Good. Now all you have to tell me is which one looks like this, negative to positive, and which one looks like this, positive to negative. That's all. So, very good. Perfect. Now I see this time I have 1, 2, 3, 4 subintervals. On the first subinterval, I never count positives. They don't change anything. So on the first subinterval, I have 2 negatives. What is the sign of the outcome? On the next subinterval, I have a negative. On the next subinterval, I have 2 negatives. And on the last one, I have 1 negative. Now I'm asking myself, what do I pick? This tells me what to pick. So what am I picking? What sign is less than? Negative. So is this ever negative? So x in it's less than or equal to So 3, union, that's it. Is this clear? Okay, let's look at a ratio this time. Let's say 69. X squared minus x minus 2, everything divided by x squared minus 4x plus 3 greater than 0. This inequality is a rational inequality. The previous one was polynomial. And the previous one was quadratic, and I didn't write it, so I want to write it. So the first one was quadratic, the second one was polynomial, and this is rational. But I claim that if you want to use my chart, you can't just yet. Can anyone tell us why? Why we cannot use the chart right away? Exactly. I have 0 on one side, but I don't have a product or I have a ratio, but I also have to have the factored form and the factored form. So, very good. So what will you say? X minus 2x plus 1. And you said x minus 3 and x minus 1. I agree. So therefore, now this is ready. X is the variable in the problem that goes from negative infinity to infinity. And now we have x minus 2, we have x plus 1, we have x minus 3, we have x minus 1. And what will be the last row? Everything. Very good. X minus 2, x plus 1, over x minus 3, x minus 1. Perfect. Now I need to establish the numbers that go in the chart, put the zeros and whatever else we'll see in a minute, and then decide upon the sign. So I'm ready when you are. And they have to be in ascending order. -1 is first, I agree, from here. Perfect. Next one. 1 from here. Perfect. 2 and 3. Each row has to have a 0. Where is the 0 in the first row? Under 2. Where is the 0 in the second row? Perfect. Where is the 0 for this one? Where is the 0 for x minus 1? Excellent. Now, what do I have under -1 for this ratio? What do I have under 1? Careful. Very good. What do I have under 2? What do I have under 3? Undefined it is. Thank you very much. Now, I look carefully. Yes, please. The denominator cannot be 0, x cannot be 3, x cannot be 1. Now, I'm looking at all these. They all look like this. So I don't have to think. I just have to copy negative to positive, because they all have a positive leading coefficient. So here it is. I see that now I have 1, 2, 3, 4 subintervals. Okay, ready? On the first subinterval, I count 4 negatives, sign. On the next subinterval, I count 3 negatives. 1, 2, 3. On the next subinterval, I count 2 negatives. On the next subinterval, I count a negative. And on the last one, no negatives. Now, only now I check this. Which sign do I have to pick? I have to pick positive. Is this expression ever positive? So x in the interval, negative infinity to -1, union. Very good. 1 to 2, union. 3 to infinity. Any questions?
Yeah.
Yes.
When you first pick your numbers on the top line, -1, 1, 2, and 3.
Yes.
What do you do?
X plus 1 is 0 when x is -1. X minus 2 is 0 when x is 2.
Right.
X minus 3 is 0 when x is 3. And x minus 1 is 0 when x is 1. We have to determine those on the side and then put this in ascending order, and then everything will. Anything else? Yeah, I would like to do 55. And then we'll continue with something else. X plus 1 divided by x plus 3 less than 2. What do I have to do first?